In this lecture, we're going to be taking a look at how you can remove data from a table. SQL supports two statements that you can use to delete rows from a table: delete and truncate. The first one we're going to be taking a look at is the delete statement. With the delete statement, you can delete rows from a table. You can optionally specify a predicate to restrict the rows to be deleted. A typical delete statement looks like this one here. You have the delete keyword from the table that you want to delete the records from. So you have the where and then the predicate. If you don't specify a predicate, all rows from the target table are deleted. As with unqualified updates, you need to be especially careful about accidentally deleting all the rows by highlighting only the delete part of the statement and forgetting to highlight the where part. So here I am creating a demo table in the person schema called person demo. So I'm using a select statement to select from the person table to create this table. So I'm just going to add a job table here first because it was already created, right? So let me execute that. Now let's execute to recreate the table. Now I'm just going to do a select from the demo table, and it's a full copy of the person table. Now let's scroll down. Now our goal is to delete all the person from the person table who has an email promotion of 2. So here I have a statement that achieves that. Delete from person demo where email promotion equal to. Now let's execute this statement. Now let's query from the demo table again. Let's scroll down, see if we have any email promotion which is equal to 2. So all the persons with email promotion 2 was deleted. So our goal is to delete all the persons from the table that has a middle name of C, right? So we're going to have the delete from, specify the table which you want to run the delete from, the where clause, and the column which you want to have in your expression. So it's this, in this case, it's middle name, and the value is C. So here we have Patrick and Daniel with middle name C. Now let's execute this delete command. Now let's do a query on the person demo. So all the users were deleted and our total roll count down as well. So if you're supposed to make a mistake and just execute this portion of the delete statement, then guess what? All your data will be gone from the table. So let's do execute on the demo table, and as you can see, it's empty. So you have to be careful when you're running the delete command. So far, the tables that we have been using in this course are very small, but in a more realistic production environment where the volume of data is likely to be much bigger, a delete statement is fully logged. Now what do I mean by this? The database have what is called a transaction log, right? And this is for recovery. Now this is assuming the database is in full recovery model. So all of what's taking place is logged to the transaction log. So as a result of this, large deletes can take a long time to complete. Now, such large deletes can cause transaction log to increase in size dramatically. They can result in lock escalation, meaning that SQL Server escalate fine-grained locks like row locks or full-blown table lock. Such escalation may result in blocking access to all the table by other processes. So the solution to this, if you want to get rid of all data out of your table, is to use the truncate statement. The truncate statement follows the syntax: truncate table and the name of the table. So if you want to truncate the person demo table, all we need to do now is write truncate table and the name of the table that we want to truncate. Now let's do a query on the table to ensure that data is in it, right? Now let's execute the truncate statement. Now let's query the table again, and as you can see, we have no data within the table. So the truncate is way faster than the delete statement. And this is mainly when you're dealing with a lot of data in a table. So the truncate statement is really an all or nothing approach. The delete and truncate statements have a number of important differences between them. The delete statement writes significantly more transaction log compared to the truncate statement. For delete, SQL Server records in the log the actual data that was deleted. For truncate, SQL Server records information only about which pages were deallocated. As a result, the truncate statement tends to be tremendously faster. The delete statement doesn't reset an identity property. So if an identity property is associated with a column in the target table, by the delete. However, the truncate statement does. Like with the update statement, we can delete using common table expression. So I'm going to recreate the table and I'm going to write a CTE to delete the top 10 records. So it's with the name of the CTE. I'm going to say CTE delete. And you say as, open brackets. Here select statement. So I'm going to paste this here. And I'm going to say top 10. Now I'm going to say delete from CTE underscore delete. Now let's execute this. Now let's query the person table. The total record count is 19,962. Now let's do a query on the person table. And as you can see for the person table, it's 19,972. Let me remove that. So just like with update, you can delete using joins and CTEs. So anything that you can do with the update statement, you can pretty much do it with the delete statement as well. Now I've left the delete and join statement for a good reason. So if we scroll down and try to do a delete using a join, we are going to run into some problems, right? So let me change this to delete. So in this case, we don't need any set because we're not updating. So it's delete from person, right? And we are going to try and delete other persons from the person table who lives in the city Bethel. Now let's execute this statement and you can see that it failed. The delete statement conflicted with the reference constraint and the name of the constraint, right? And it goes on to say the person address table. And it also gives the column which it has a conflict with. So this is because the constraints are enforcing referential integrity. So if we try to delete a person, the person has a reference in the person email address table, right? So if we try to delete a person from the person table and there's a reference in the person email address table, then it will throw an error because now we need to delete the data that is in the person email address as well. So what I'm going to do now is that I'm going to create a database diagram for you to get a clear understanding of this. So we're going to need the address, we need the person, we need the business entity, I need a person from the person schema. I need the business entity address, right? So let me select those here. So this is the relationship between all of the tables. So let's assume all of this information you're seeing here is one record. Now, if I delete this record from the person table, I now need to go and delete the same record from the business entity person. I then need to go and delete the record from the business entity address and then as well as the address table. And this will help to enforce our data integrity, because if we delete the record from here and the associated record from these tables are not deleted, then basically we end up in a situation where we have missing data and then this data is not of high integrity, right? So this is where the cascade statement come into play, which we'll take a look at in the next lecture.